Okay, here's a question from May 2024 past paper, question number 7, International Pure 2. The circle has this equation: x squared plus y squared plus 8x minus 10y is equal to 29. Find the coordinates of the center C1. Find the exact value of radius of C1 for 3 marks. Okay, so let's do the part A first. So in order to find the center and the radius of circle, we need this expanded equation into this form. Okay, x minus a squared plus y minus b squared, okay, is equal to r squared. Hence the center is going to be AB square root of r squared, which is just r. So how we can express into this form? By completing the square. Okay, so x squared plus 8x plus y squared minus 10y is equal to 29. I collect terms on one side and in this side, okay, y terms are here and x terms towards here. Now we apply completing the square. So x plus 4, half the coefficient of x, minus 4 squared, which is going to be 16, plus y minus 5 squared, minus 5 squared is what? 25 is equal to 29. Alright, so we can take this and this terms to other side, so that is going to give us 70. Alright, so x plus 4 squared plus y minus 5 squared is going to give us 70. Hence the center is going to be 4 minus 4 and 5, and the radius is going to be the square root of 70. Okay, there is no need to do any further thing over here. You just leave in this form as it says for exact value. Alright, so this is the answer to this question. Here's our 3 marks done. Okay, now the circle C2 has this equation: x minus 5 squared plus y plus 8 squared is equal to 52. Prove the circle C1 and C2 no touch or no intersect for 3 marks. For approaching this type of question, it is better that we draw a sketch of C1 and C2. So here's C1 and here's C2. Alright, and we have to show that they don't intersect. We cannot use points of intersection and find the discriminant. That's not going to work because that is unrealistic. So the center is minus 4 and 5, and the radius is root 70. No, for this question, plot everything you know, okay? Do whatever you know. Draw a sketch, okay? And here's a center of C2 is going to be 5 and minus 8. And the radius is going to be root of 52. now from here, how we can prove that the circle C1 and C2 don't intersect? Well, what we can do is find the distance between center C1 and center C2. How we can do that? Well, by using the distance formula. And what we can do that we can add these two radiuses, which is going to be the less between the distance of C1, center C1 and center C2. Okay, so first we find the distance between the center of C1 and center of C2. Okay, so distance is going to be the square root of -8 minus 5 squared plus 5 minus -4 squared. Plug this into your calculator. You would get distance is 5 root 10. Well, 5 root 10 can be written as root of 250. Okay, so this whole distance is between the center is root 250. Now we need to add these two radius. Okay, add these two radiuses, so root of 70 plus root of 52, and that should be less than root of 250. So root of 70 plus root of 52 is going to give us 15.6 to 1 decimal place, and root of 250 is going to give us 15.88, okay, to 1 decimal place. Now what we can understand, that these two radius and these two radius, when they are added up, it is going to be the less than the distance between these two centers. So that means that there is going to be a gap between the circles. Now if there is a gap between the circles, this clearly means that they don't touch nor intersect. Now if these two circles, if they were intersecting, if we added the both radius, that should give us greater than the distance between the centers if they were touching or intersecting. Okay, so this is the only question they have given for proof that they don't touch or intersect. Yeah, bit tricky, but you have to think logically. Okay, all right, thanks.